Hi everyone, this is your Srinivas Rao Physics NEET and IIT faculty. Welcome back to my channel. Today I am going to discuss about three masses M1, M2 and M3 located on smooth horizontal surface. In this case, we wanted to calculate acceleration of the system of masses and tension in the strings. Here three masses connected by strings. Here F be the applied force for the system. Here applied force F directly acts with the mass M1. Remaining two masses only affected by applied force F indirectly. We want to calculate acceleration of the system, T1 and T2 tensions in the strings. In previous class already we discussed motion of the bodies connected by strings with M1 and M2 only. But today we are going to discuss three masses connected by strings. In this case we want to calculate acceleration, tension T1 and tension T2 in the strings. What is tension? Tension is nothing but tightness of the strings. The tightness produced by one body to another body. In this case, T1 tension produced by mass M2 in a string with respect to mass M1. Next, T2 tension produced in a string due to mass M3 towards mass M2. So like this, in opposite manner, T1 and T2 tensions produced with respect to one body to another body. In this case, first we have to write the free body diagram for mass M3. Before going to free body diagram, here three masses M1, M2 and M3 located on smooth horizontal surface. Without friction, we are going to discuss the acceleration of the system and tension in the strings. There is no frictional force between the bottom surface of the masses and smooth horizontal surface. Here frictional force F is equals to 0. First we have to write the free body diagram for mass M3. Free body diagram for mass M3. So we have to write acceleration. What is the acceleration here? System of three masses accelerated along the negative x-axis. Here M3 mass also accelerated along the negative x-axis with tension of the string T2. Here M3 not directly accessed by applied force F. So we have to write net force on the mass M3, that is equals to tension in the string. Directly you have to write T2 is equals to M3A. Here M3A be the net force acts on mass M3, that is equals to tension in the string T2. This is equation 1. Next we have to write the free body diagram for mass M2. Here mass M2 affected by two tensions, T1 and T2 tensions. T1 tension due to mass M1, T2 tension due to mass M3. Then mass M2 accelerated along the negative x-axis. Write the free body diagram for mass M2. So what is the free body diagram here? In this case, we have to consider the mass M2, T1 tension along the negative x-axis due to mass M1, T2 tension along the positive x-axis arised due to mass M3, but M2 mass accelerated along the negative x-axis. From this diagram, we have to write the expression. Here mass M2 accelerated along the positive x direction in the sense T1 tension dominates the T2 tension. So we have to write the expression for mass m2. Okay, the net force acting on the mass m2, F net is equals to T1 minus T2, because here T1 dominates the T2. Body accelerated along the positive x-axis. According to Newton's second law, what is F net? F net m2a is equals to T1 minus T2. Already we know T2 tension. Okay, so substitute the value of T2 in equation 2. Already we got tension in the string T2 is equals to M3A. This is equation 1. From the free body diagram for mass M2, already I wrote T1 minus T2 is equals to M2A. This is equation 2. From equations 1 and 2, okay, first we have to write the T1 tension in the string. T1 minus M3A is equals to M2A. T1 is equals to M2A plus M3A. A taken as common, T1 is equals to M2 plus M3 into A. This is the expression for tension in the string T1. This T1 exerted by both masses M1 and M2. Due to mass M1, the tension of the string towards mass M2. Next, T1 tension exerted by mass M2 towards mass M1. So here two directions mentioned in a string. This is equation 3. Next, we have to write the free body diagram for mass M1. Free body diagram for M1. In case of M1, applied force F directly accessed. Next, tension of the string due to mass M2 on mass M1, okay, along the positive x-axis. The acceleration of the mass M1 along the negative x-axis in the direction of applied force. From this free body diagram, write the net force on M1. F net is equals to, here applied force dominates the tension T1 because the body M1 accelerated along the negative x-axis. So we have to write F minus T1. F minus T1. Next, what is F net here? According to Newton's second law, M1A is equals to F minus T1. Already we got T1. Substitute T1 in this equation. M1A is equals to F minus M2 plus M3 into A. From this equation, we have to write applied force F is equals to M1A plus M2A plus M3A. Here A taken as common, M1 plus M2 plus M3 in bracket. This is the expression for applied force. Already we got the expression for applied force F is equals to M1 plus M2 plus M3 into A. From this equation, acceleration of the system of masses A is equals to F by M1 plus M2 plus M3. This is the expression for acceleration of the system. Next, we have to write the expressions for tension T1 and tension T2. Already we got tension T1. Tension T1 is equals to M2 plus M3 into A. Substitute the value of acceleration in T1. Then T1 is equals to M2 plus M3 into F by M1 plus M2 plus M3. This is the expression for tension in the string. This tensional force belongs to M1 and M2 masses out of entire system. Here T1 be the tensional force exerted by mass M1 towards M2 or exerted by mass M2 towards T1. Next we have to write the expression for tension in the string T2. So already we got T2 is equals to M3A. T2 is equals to M3 into F by M1 plus M2 plus M3. This is the expression for second tension. T2 be the tensional force between masses M2 and M3. So here tensional force T2 exerted by mass M2 towards M3 or exerted by M3 towards M2. So from this system of three masses connected by strings, we can easily solve the acceleration of the system and T1, T2 tensions in the strings. Okay, we can easily solve the expressions. Okay, we know the free body diagrams. So children, so everyone first based on the diagram, understand the concept, then write the expressions from the data. Thank you everyone.